Now for question number 11, the first part is there's a plane, it has this equation. We need to find a vector normal to pi 1, that is a plane pi 1. Now remember there's two direction vectors here. Okay, and the first one is there. We can cross product these two direction vectors. And this is 0, 2, minus 1. The other one is 3, 2, minus 2. And therefore, if we cross product, we're going to get minus 4 minus minus 2, which is minus 2i. Then you block this. This is going to be equal to minus 3j, and this is minus 6k. And here we are. That's a normal, first part. And we need to show that the equation pi 1 can be written as in the Cartesian form, 2x plus 3y plus 6z is equal to 14. Now for this one, it is very simple. We're going to use equation of a plane, which is basically r dot n is equal to a dot n. And in this particular case, we have r as xyz dot n, which is minus 2, minus 3, minus 6, and that's going to be equal to a dot n. The coordinate is 1, 2, 1, that's a. So it's 1, 2, 1 times minus 2, minus 3, minus 6, and this leads to, you can see minus here, minus on both sides, so we can divide by minus 1, and this is going to lead to 2x plus 3y plus 6z is equal to 14, because 1 times 2 is 2, 2 times 3 is 6, 6 plus 2 is 8, 1 times 6 is 6, 6 plus 8 is 14. Okay, that's the first part done. Okay, for the second part, there is a line, and this is the line with that equation, and the point L where t is equal to lambda, this t is going to be lambda, is denoted by p. P will be a general point on this line, and we need to find the set of values of lambda for which the perpendicular distance of p from pi 1 is not greater than 4. What I've done here is I've just drawn the plane just like that, a rough illustration, and this is p, and the distance here is not, it should be less or equal to 4. Alright, that's the perpendicular distance. Now a general point on the line is given by the equation of the line itself, which is 3 plus 4t, and t is lambda. Here we are, 3 plus 4t, 8 plus 6t, 2 plus 5t. And then we can take a general point in the plane itself, okay, and the plane is here, it has this equation. If I put y0 and z0, then 2x is equal to 14, meaning that x is equal to 7. So we've got 7, 0, 0, which is any point in the plane. So from here, we have a point, let's say Q. Alright, so what we're going to do is we're going to find PQ. And PQ is Q minus P, which is 7 minus this, that's going to be 7 minus 3 plus 4 lambda, which is then 7 minus 3 is 4 minus 4 lambda. And you've got 0 minus this is going to be, we can put this as I, we can put this as minus 8 minus 6 lambda, j plus then the last one is going to be 0 minus this one here is going to be minus 2 minus 5 lambda, and this is k. Now what we're going to use the formula for perpendicular distance from a point to a plane. That's going to be basically PQ dot n divided by n. Okay, take the absolute value of all of that, and that is going to be less or equal to 4. Alright, because the distance is less or equal to 4. So if we take this and we dot product with n, where n is the normal to the plane, 2, 3, 6. Okay, so what we're going to do, so this leads to 4 minus 4 lambda, okay, I plus minus 8 minus 6 lambda, j plus minus 2 minus 5 lambda, k, dot product with the direction vector, which is 2i plus 3j, okay, plus 6k, and take the absolute value of all of that, say it is less equal to 4 divided by the magnitude of the normal, 2 to the square, 3 to the square, plus 6 to the square. And let us see where we go with this. So 4 times then 2 is 8. Okay, we got then 8 minus 8 lambda, minus 8 times 3 is minus 24. You got minus 24, and then 6 times 3 is 18, minus 24 minus 18 lambda. Also we've got minus 2 times 6, which is minus 12, then minus 30 lambda. All of that divided by the square root of 49, less or equal to 4. Remember, this is the absolute value. So now, if we take this further, we're going to reach minus 28 minus 56 lambda over 7, less or equal to 4. If you were to solve this, you should be able to get t, which is lambda, basically as 0, and then lambda is equal to minus 1. And because we're taking less, so we're going from minus 1 less equal to lambda less equal to 0. So these should be the set of values of lambda for which the perpendicular distance from a point on the line to the plane is less or equal to 4. Second part done. Now the third part to this question is the plane pi 2 contains L and the point with position vector 1, 2, k. Find the acute angle between pi 1 and pi 2. So we need an equation for pi 2. Maybe it's direction vector to start with. So let us say that this is the plane. Okay, this is pi 2, for example. Okay, in this plane we have a line, and the line has the equation line L, and line L has been given in the question as this. So there is a coordinate there and its direction vector. So coordinate is 3, 8, 2. So we have 3, 8, 2. That's a coordinate. And there's a point in the plane, and the point is 1, 2, 4. 1, 2, 1. So there we go. 1, 2, 1. To start with, we can just call this, if we want, find the direction vector of this. Let's call this A and B. So maybe we can find AB. And AB is basically 3 minus 1, which is 2i, 8 minus 2, which is plus 6k, and then 2 minus 1, j, and then k. Alright, 2 minus 1 is 1, which is k. Okay, this is AB. And the direction vector of this line is 4, 6, 5. So we've got then 4, 6, 5. Direction vector of the line is 4, 6, 5. Now we can cross product again. We can create a normal to the plane. Okay, so this is I, j, k. 2, 6, 1, 4, 6, 5. Cross product, you're going to get 30 minus this, which is then 30 minus 6 is 24. I, this one is 10 minus 4 is 6, so minus 6 j, and then plus we're going to get this one 12 minus 24, which is then minus 12k. Right, now from here what do we do? Okay, so the other plane, we need to find the angle between this plane. Let's say this is the other plane going like this, something like this, the angle between these two planes. This is plane pi 1 and pi 2. What's the direction vector of the other plane? Its direction vector is 2, 3, 6. Okay, so what we're going to do is we're going to put, let's call this angle gamma. So we're going to say gamma is equal to cos inverse of these two. 24 minus 6j minus 12k. That's going to be dot product with 2i plus 3j plus 6k. Okay, and all of that should be divided by their magnitude. 2 to the square is 4 plus 9, 13, 13 plus 36, 13 plus 36 is 49, times here we can get an equivalent vector to this, which is if we divide by 6 you're going to get 1, 2, 4. So we can say 4 to the square plus 2 to the square plus 1 to the square, 21. So we have root of 21. So let us see, 24, let's say 4 times 2 is 8. Okay, so we've got then 8 minus 24, 8 minus 1 times 3, 8 minus 3, and then 2 times 6 is minus 12. Okay, so that's going to make it minus 7. Cos inverse of this is 4 times 2, which is 8. Okay, let's see here, 8 minus 1, divide by 6 is 1. 1 times 3 is 3, so minus 3. Then divide by 6 is 2. 2 times 6 is 12, so minus 12. They got minus 7. Minus 7 divided by 49. Root of 49 is, then that's going to become 7 over 7, which is 1, minus this whole thing. Remember, we need to find the acute angle. So we can say cos inverse in brackets minus 1 divided by root of 21. That's going to give you this much. 102.604 and so on, and therefore take 180 minus the answer. This acute angle between these two planes, gamma, is then 77.4. Right, so this should be the answer to that question. And here we are, this whole answer here, and this is coming from the November 2008 further maths. Okay, so October, November 2008 further maths, code 9231, paper 1. This is question number 11, which carries 12 marks. Not bad, for a 12 mark question. 12 mark question. Well, hope this is going to be of help. Take care.